complete feed technology, an alternative approach for feeding of ruminants. There is tremendous pressure on livestock available total feed and fodder, as land available for fodder production has been decreasing. To meet the current level of livestock production and its annual growth in population, the time has come to explore and utilize non-conventional feeds so that the feed requirements for livestock can be met and the competition between humans and livestock for common food grains can be reduced. In India, over 500 million tons of agricultural residues are produced every year. The amount of surplus crop residues available in India is burnt annually. But burning of crop residues not only degrades the atmospheric quality, but also affects the climate and ultimately human health. The alternative, therefore, would be the use of these agricultural residues to feed livestock. The principal residues used as livestock fodder are the straws of cereals, pulses, and byproducts from oilseed processing, grain milling, and other agro-industrial activities like fruits, vegetables, brewery waste, etc. Utilization of crop residues. Crop residues are assuming a prominent place in smallholder ruminant production systems. However, crop residues, being unpalatable and low in digestibility, cannot form a sole ration for livestock. Crop residues are low-density fibrous materials, low in nitrogen, soluble carbohydrates, minerals, and vitamins with varying amounts of lignin, which acts as a physical barrier and impedes the process of microbial breakdown.
Many of the farmers are utilizing the advanced technologies by feeding the animals using complete feeds, wherein we can incorporate different levels of agro-industrial products in the complete feeds. The processing of agro-industrial residues by supplementing them with molasses and or urea also helps to enhance the nutritional availability of the nutrients present in the byproducts. Mainly, the utilization of byproducts reduces the cost of feeding and also enhances the nutritive value of the complete feeds.
To meet the nutritional requirements of animals, the residues need processing and enriching with urea and molasses. Processing of crop residues. Any processing method that improves the nutritional value of these crop residues will enhance the density of nutrients per unit of feedstuff and will go a long way to bridge the gap between availability and requirement of roughages to existing livestock population. In this aspect, improving the utilization of available feed resources by processing to overcome the scarcity situations in a cost-effective manner and reducing feed cost per unit of product are the major issues needing attention. The processes include physical, chemical, and biological methods. Most of the methods have been technically successful and have been exhaustively investigated. Crop residue-based complete feed technology for ruminants. In this system, all feed ingredients, inclusive of roughages, are proportioned, processed, and mixed into a uniform blend, supplying adequate nutrients to the animal. The product is fed as a sole source of nutrients. This system ensures the supply of balanced nutrients, controls the ratio of concentrate to roughage, helps in improving utilization of low-grade fibrous agricultural residues, reduces feed wastage, and also feeding cost. It also promotes better consumption and avoids refusal of unpalatable proportion of the feedstuffs. This system gives good scope for increasing the use of homegrown fibrous agricultural residues and byproducts. The major advantage of using complete feeds has been reported to be useful to induce animals to consume proper proportions of roughages and concentrates for optimum performance. The roughage content of complete diets is 30 to 40% of high-yielding animals, 40 to 50% of growing animals, and 60 to 70% for dry animals, whereas the protein content varies from 11 to 13%. These diets can be processed into mash, pellets, or blocks.
The main objective of this complete diet system is to provide the nutrients like energy and especially critical nutrients like nitrogen, minerals and vitamins at the same time to the microbes which are inhabiting in the rumen ecosystem, and so that the microbial biomass production can be efficiently improved.
MASH. The different ingredients of a diet are proportioned as per formula into 100 kg batches using appropriate scales. A hammer mill with a 8 mm sieve is used for grinding the ingredients. Through screw conveyor and bucket elevator, the ground ingredients are discharged into a hopper fixed on top of the mixer, and the ground material is mixed for 10 minutes. Expander extruder processing. This is a system which combines the feature of expanding, which is application of moisture, pressure and temperature to gelatinize the starch portion, and extruding, which is pressing the feed through constrictions under pressure. The finished feed will come out in the form of pellets. Densified feed blocks. The process of block making from low bulk density roughage resources substantially reduces the cost of labor, transportation, storage, and ensures uniform supply of nutrients for optimum rumen fermentation. Densification of complete diets increased the bulk density 3.2 to 3.9 times. The shape of densified material may be square, circular, or quadrangle, depending upon the type of dye used in the machine. Feeding of complete feed block ensures 25% higher dry matter intake in calves and 35% higher live weight gain in heifers.
నా పేరు జంగయ్య, నాది బుద్ధివల్లు. సంతకు పోయిన 70,000 పెట్టి తెచ్చిన వరిగడ్డి సొప్ప. నాకు భూమి లేదు ఏది లేదు. జంగాలకి వెళ్తే మేపుతా. ఈ జంగాలకి వెళ్ళి మేపితే లీటర్ భావించింది. ఇక మన యూనివర్సిటీ వాళ్ళు దాన్ని తయారు చేసి ఇచ్చేది. దాన్ని తయారు చేసి ఇచ్చిన తర్వాత దానివలన దానికి మంచిగా ½ లీటరు ఎక్కువచ్చినాయి నాకు.
Hence, in a world with less and less land available for livestock, these different methods can be used for agricultural residues repurposing, representing a huge opportunity for livestock feeding and therefore animal production.